In Lesson 54, we'll be solving pairs of equations that are called simultaneous equations. Now, to understand how to solve these things, there's a couple things you need to think about first. For example, we've been doing evaluate problems for a while, where maybe you had an expression like a squared b, and you were supposed to evaluate that when a equaled 1 and b equaled 2. And what you would do was substitute those values for a and b into that expression and solve it. Now, when you did that substitution, you were following a mathematical guideline called the substitution axiom, and that just states that if you have an equal quantity, like you're saying A is equal to B, you can replace A with that quantity. So we can replace A with 1, and we'd have 1 squared. We can replace B with 2, and we have 1 squared times 2, and then we can get a solution which equals 2. Now, it doesn't matter if we would have said A equals 1, or we could have even said A was some kind of variable. We could erase this and say A equals X. You would still substitute, or you still could substitute that in for A. It doesn't matter if it's a number or a variable. If it's a variable, we could just say X squared times 2 equals 2X squared. So it doesn't really matter if it's a number or a variable. As long as we state that those relationships are equal, A equals X, B equals 2, then we can substitute those values of X and 2 in for A and B respectively. Now, keep that thought in mind about substitution, and let's talk about what simultaneous equations are. Now, the word simultaneous, maybe that rings a bell. That means basically together or at the same time. And that's what we're doing. We'll have a pair of equations, and they'll be first degree polynomial equations like these two here, y equals x plus 1 and y equals x minus x plus 2. And we'll solve those together. And first though, let me go ahead and graph those two relationships. You know that those polynomial equations like that are first degree and two unknowns in them, those represent lines. And the first one, y equals x plus 1, would basically be a line like that. And then y equals minus x plus 2 would be a line pretty much right through there. Now notice those two lines intersect each other. There's a point where they intersect. Right here where I'm making that blue dot. There's one and only one position where they intersect, and it happens to be at 1/2, comma 3/2, or 1.5. So we go to the right 1/2 and up 1.5, and that's that intersection position. Now that's what we'll be doing when we solve simultaneous equations. We'll be finding that intersection point of those two lines. Now we could always graph our lines and find it using a graph, but graphs usually aren't quite as accurate as doing the mathematical formulas. When we do it mathematically, we can get the exact x value and the exact y value of that point of intersection. So how do we solve these simultaneous equations? Well, we use our substitution axiom to help us. Look at the first equation there. Y equals x plus 1. Look at the second one. Y equals minus x plus 2. So we have relationships there describing what y is. So couldn't we just take the second relationship and substitute it in right there for y? Since we're solving these things together and we're trying to find where they intersect, we have to find out how they relate. And so we have to say that y is equal to each other when they intersect, which it is, right? The place where they intersect, y is equal for both of them. And so now we can substitute that in, and I'll just say minus x plus 2 is equal to x plus 1. And we can solve that for x. See, now we have one equation and just one unknown value, and so we can solve it for a specific numerical answer. And so we add x to both sides, and at the same time, why don't we just go ahead and add a negative 1 to both sides. So the x's cancel there, the 1's cancel here, and we end up with 1 is equal to 2x. Divide both sides by 2, and we get x equals 1/2. So we have half of that point there where the intersection is. So how do we get the y value? Well, we could substitute that x back into either of those two equations. It doesn't matter which one we do. Let's do the first one. Y equals 1/2 plus 1. That equals 3/2, or 1.5. Let's use the second one just so I can prove to you that it doesn't matter which one you use. Y equals negative 1/2 plus 2, which is also the same thing as 3/2. So when we solve equations simultaneously, we're solving for where they intersect. We're finding the place where they're basically equal to each other on a Cartesian coordinate system. We do this by using our substitution axiom. If we have expressions of equal value, in this case we have two expressions that both equal y, we can substitute one of them in for the other one. Let's go ahead and do a practice problem. Usually these simultaneous equations, there's braces put on one side of them to help you just think about them being together. And when we solve them, keep in mind when we solve simultaneous equations, we're solving for where those two lines intersect. Now these don't look like the equations of lines. They don't exactly look like the equations of lines that we've been working with, but they have the appropriate variables, right? They're first degree polynomials. They have an x and a y in them. So it's just a matter of rearranging them to get them to look like y equals x plus something else. All we need to remember on these is to solve this, to find that point of intersection, we start by using the substitution axiom. And we just find the easiest way to do that. Look at that second equation. X equals y minus 5. So we have an example there of what x equals. Let's just go ahead and take that y minus 5 and we'll substitute that in right here in the first equation for x. And so we'll say 2, you need to use parentheses, times y minus 5 plus y is equal to 14. Okay, now we can expand that. 2 times y is 2y, plus 2 times negative 5 would be negative 10, plus y equals 14. Okay, now we need to simplify by adding like terms, and so we'd have 3y minus 10 equals 14. Add 10 to both sides. Let's just do that in our head. 3y is equal to 24. Divide both sides by 3. Y is equal to 8. Okay, so now we have a numerical value for y. Let's go back and figure out what x is. And let's use that second equation up there. X equals 8 minus 5. So that equals 3. So x is 3 and y is 8. We need to write our answer like an ordered pair. 3, 8. It's not 8, 3. Remember, you do x first, y second. So there it is, 3, 8. If we drew those two lines on a Cartesian coordinate system, and you could do that if you want to, just set them equal to y, and then go ahead and make your xy table up, plot your points, you would see that they would intersect at 3, 8. If you do this and you do the graph for it, they may not exactly intersect at 3, 8, but that's because you maybe made a couple of mistakes along the way in your graphing. Let's do one more. Let's use substitution to solve these two equations. Now, there is more than one way to solve these simultaneous equations. The way that we're learning right now is called the substitution method. Later on, you'll learn something called the elimination method. But let's just keep the substitution method in mind right now, and we just know that when we do these simultaneous equations, we're solving for where those lines intersect. So that means we can say that the y in 3x plus 11, when it equals 3x plus 11, we could substitute that 3x plus 11 value into the second equation there. That would be the easiest thing to do, and then we could go ahead and solve for x first. So we'll say 2x plus 3x plus 11. That's going in the place of y in that second equation. Equals negative 14. So let's go ahead and simplify. On the left there, we'll have 2x plus 3x is 5x plus 11 equals negative 14. Add a negative 11 to both sides, and we have 5x is equal to negative 25. Divide both sides by 5, x equals negative 5. So there's our value for x. Now let's go back and figure out what y is. We could substitute that x value into either of those equations, but it'd obviously be easier to do it into the first one since it's already set equal to y. So we'll say y equals 3 times negative 5 plus 11. And so y is equal to negative 15 plus 11, which equals a negative 4. So now we have x and y. Let's write our answer as an ordered pair. Negative 5, comma, negative 4. We always write our answer as an ordered pair, x, comma, y. So in this problem, we're solving a simultaneous set of equations, and we knew that we could take this 3x plus 11 and substitute it in right here for y in the second equation. Since it equals y, since 3x plus 11 equals y, you can substitute it in. We solved for x first, then we went back and solved for y, and we made our ordered pair. We write it as an ordered pair because, remember, when we solve these equations, we're solving for where those two lines intersect. And so if we graph those lines, they would intersect at minus 5, comma, minus 4. Okay, well that's all for lesson 54.